this video, we'll discuss how to find the time variable in a compounded interest formula. And again, we're going to use this formula for compound interest. And the question says, how long will it take an investment? So how long will it take me in finding time? An investment of $10,000 to grow to an amount of $12,000 if it is compounded monthly. So here I know I'm using the compounding formula. A equals P times 1 plus R over N raised to the NT. And I know that I want it to grow from 10,000. So the present value of that money, or the P, is 10,000. And the future value of that money, or the A, the ending balance, is 12,000. So $12,000 is equal to 10,000 times 1 plus, and the rate here is 0.09. Compounding it monthly, so I'm going to compound it 12 times in a year. And I want to figure out how many years I need to do that for. So I'm going to get 12 to the T. 12 times T. Now, in order to solve this, remember what I told you. If you know the principal and the ending balance are the future value and the present value, you know both those, you always divide by the principal first. So we're going to divide both sides by $10,000. And so when I do that, 12,000 divided by 10,000 is 1.2. So I have 1.2 is equal to, and I'm going to clean this up right here. So it'll be 0.09 divided by 12. Plus 1. And I get this number here. So this will be equal to 1.0075 raised to the 12t. Now, to undo this exponent, because right now there's a problem with this. The t is sitting in the exponential spot. So this becomes an exponential that I need to undo. In order to undo an exponent, I have to take logarithms. And in particular, I'm going to take the natural log. And there's a property in natural logs that says when you have a power like this, if you introduce the natural log to both sides of the equation, so what I mean by that is this, I'm going to take what we call the natural log as ln. So if you see ln, this means natural log. And this is the inverse of the exponential, or e. So I can take the natural log of the left-hand side, the natural log of 1.2, and I can also take the natural log. If I do it over here, I have to do it over here as well. When I take the natural log of this side, though, this 12t moves to the front of the natural log. So I get 12t natural log 1.0075. And you just do the natural log using your calculator. So now I want to solve for t. So what that means, I'm going to divide by everything that's not t. So I'm going to divide this by 12 natural log 1.0075 on both sides. And when I do that, I divide the natural log, which is the ln button in your calculator, 1.2 divided by, and when you divide this, make sure you keep this correct. And I like to use parentheses. I always, in my calculator, I'll use parentheses around this bottom part because I need to do all of that together. So I'm going to do parentheses, open parentheses, 12 times the natural log of 1.0075, close parentheses, and press enter. And I get a t of approximately 2.03 years. And this measurement we're calculating in is years, by the way. So you're going to get the years there. It's 2.03 years. But when you're trying to find t, remember you have to use the natural log for this now.